June 1944. A German reconnaissance plane crosses the Normandy coast and brings home a strip of film that should have shown nothing unusual. Fields, hedgerows, a few farm lanes behind Omaha Beach. The same kind of French countryside Luftwaffe interpreters had been staring at for weeks. But when the photographs are developed, one frame stops the room cold. Where there had been pasture 3 days earlier, there is now a runway. Not a sketch, not a construction site, a working runway. 35 meters wide, nearly 1,000 meters long, fighter aircraft parked along the edge, fuel trucks moving on roads that had not existed when the last photographs were taken. A control point, revetments, men in olive uniforms directing traffic across ground that had been a farm track on Monday. The interpreter checks the coordinates. Then he checks them again. The shadows match. The trees match. The village line matches. Only the field has changed, and the change is impossible. Because, in the German understanding of war, airfields did not appear in 3 days. They were surveyed, graded, drained, poured in concrete, cured, finished, wired, protected, built by engineers, labor battalions, contractors, and time. A proper airfield belonged to the category of permanent things: a railway station, a bridge, a fortress. Not something that rose out of wet farmland between one reconnaissance flight and the next. And yet the photographs kept coming. Another field behind the beachhead. Then another. Then another. Every morning, German intelligence saw more runways where there had been open country. Every afternoon, P-47 Thunderbolts and fighter bombers from those runways hit German convoys, strafed armor, cut roads, and killed movement before it could reach the front. The German question was not rhetorical. It was not even disbelief anymore. It was an engineering question. How were the Americans building airfields faster than the Luftwaffe could update its maps? The answer begins with a strip of steel 10 feet long, 15 inches wide, and punched with 87 holes. But the steel was only part of it. The real answer was a whole country that had spent the previous decade teaching ordinary young men how to build roads, drain ground, run tractors, move earth, and finish a job before sunset. And when that country went to war, it did not merely send aircraft overseas. It sent the men who could build the ground underneath them. To understand why the German reports sounded so astonished, you have to start with the German idea of construction. The Third Reich believed in monumental engineering. The Autobahn, the Atlantic Wall, U-boat pens with concrete roofs so thick that bombs shattered against them, air bases with hard standings, hangars, workshops, barracks, lighting systems, drainage, and concrete runways arranged for decades of use. Fritz Todt had built an empire of construction before his death in 1942. Albert Speer inherited it and expanded it into one of the largest building machines on Earth. Organization Todt could mobilize hundreds of thousands of workers. It could pour concrete on a scale few countries could even imagine. Between 1940 and 1944, it put roughly 17 million cubic meters of concrete into the Atlantic Wall. That was its strength. It was also the trap, because the German construction system was built for permanence. It thought in seasons, not hours. It planned for installations that would last. It was brilliant at making fixed things difficult to destroy. But by 1944, the war in the West was no longer a war of fixed things. It was a war of movement. And movement punishes anyone who insists that the ground must be perfect before it can be useful. The Americans made a different bargain. They accepted ugly airfields, temporary airfields, runways with rough edges, mud beside the taxi lanes, fuel points set up beside hedgerows, and surfaces made from steel panels laid over packed earth. They did not ask whether the airfield would last 20 years. They asked whether it could launch fighters this week. That question changed everything, because a runway that lasts 60 days and exists tomorrow is more valuable in a moving war than a perfect concrete base that will be finished after the front has already passed it by. In 1939, the United States Army Air Corps saw the problem before most people understood the coming war. If American aircraft were going to fight overseas, they could not depend on permanent bases alone. They would need advanced fields in jungles, deserts, islands, farm country, coral, clay, mud, and sand. They would need places where aircraft could land before there were paved roads, reliable water, or even cleared ground. The traditional answer was the Army Corps of Engineers, and the Corps could build magnificent airfields. But magnificence was a peacetime luxury. General Henry Arnold understood that the air arm needed engineers who moved with aircraft, not behind them months later. So the Army created the Engineer Aviation Battalion. Each battalion was small enough to move, but heavy enough to build. 27 officers, 761 enlisted men, more than 200 pieces of construction equipment, a fleet of vehicles, tractors, graders, scrapers, shovels, rollers, pumps, mixers, crushers, and repair tools. It was not just a military unit. It was a road-building company in uniform. And that matters, because America did not have to invent road builders from nothing. It already had them. The Great Depression had done something no enemy intelligence file quite understood. It had put millions of American boys to work with axes, trucks, grading tools, concrete timber, drainage ditches, and roads. The Civilian Conservation Corps was not created as a military program. It was created to keep young men alive, fed, paid, and useful during economic collapse. But from 1933 through the early 1940s, CCC camps taught a generation the practical grammar of construction: how to clear a line through rough country, how to cut a drainage ditch so the road would survive the first rain, how to read grade by eye when the instruments were not enough, how to move earthen crews, how to keep working when the weather turned bad, how to obey a foreman who wanted results before dark. Then the draft came, and men who had spent their teenage years building fire roads, park roads, bridges, trails, culverts, and dams walked into induction centers, already knowing things no basic training program could quickly teach. They knew machinery, they knew dirt, they knew what wet ground would do under weight. They knew how to make something serviceable, even when it was not pretty. Add to them the dam workers, tunnel diggers, steel men, county road crews, mechanics, farmers, welders, and boys who had been driving tractors since they were 14. By 1941, the United States had a military-age population with an unusual depth of practical mechanical skill, not elite engineering skill only at the top, distributed skill, ordinary skill, useful skill, the kind of skill that turns a machine from an unfamiliar object into an extension of the hand. The machine that embodied that advantage was the Caterpillar D7, military designation, tractor heavy M1. It weighed roughly 13 tons. It was diesel-powered, tracked, stubborn, and hard to stop. With a blade mounted at the front, a D7 could push trees aside, level ground, cut drainage, open access roads, spread fill, and scrape a runway into shape. Between 1940 and the end of the war, Caterpillar produced tens of thousands of D7 tractors across several series for military use. To a German planner, this was a production statistic. To an American aviation engineer battalion, it was something more intimate. A man climbing into the seat of a D7 often did not need to be taught what a tractor was. He had driven one on a farm, or something like it on a road crew, or a crawler tractor on a CCC job. The Army had to teach him the military mission. It did not have to teach him the feel of a blade biting into earth. That difference saved time. And time was the one material the front never had enough of. Still, a bulldozer alone does not make a runway. Soft ground swallows aircraft wheels. Mud turns victory into a parking lot. Sand shifts. Clay holds water. Coral tears tires apart. So before the United States had even entered the war, Army engineers began studying portable runway surfaces. The British and French were already experimenting with temporary landing mats. The U.S. Army sent the problem to Fort Belvoir, Virginia, where the engineer board worked with civilian steel expertise. One of the key figures was Gerald G. Grulich, a steel engineer connected with Carnegie, Illinois Steel. The first test panels were solid ribbed sheets. They worked. They were also heavy, awkward, and bad at drainage. So the engineers removed steel. They punched holes in it, 87 holes per panel. The result was lighter, grippier, better drained, and easier to handle. The finished panel looked almost too simple to change a war. 10 feet long, 15 inches wide, 66 pounds. Low-carbon steel. Hooks on one long edge, slots on the other. 2 men could carry it. A crew could lock one panel into the next in seconds. And across prepared ground, a runway could grow like a steel carpet being unrolled by hand. Its first major field test came near a railway stop in North Carolina called Marston. The name stuck, Marston Mat. Later, the official language would call it pierced steel planking, or PSP. But to the men who dragged it, dropped it, locked it, repaired it, cursed it, and flew from it, it was Marston Mat. By December 1941, American factories had already produced millions of square feet. By the end of 1942, dozens of factories were involved. By early 1944, more than 180 million square feet had been shipped overseas. By the end of the war, production would approach 2 million tons. That number is enormous. But the more important number was this. One Liberty ship could carry enough mat for a full runway in a portion of its cargo space. Unload it, move it inland, prepare the ground, lay the panels, and in days, aircraft could operate where there had been no airfield at all. Not a perfect base, not a permanent base, a working one. And in war, working beats perfect when perfect arrives too late. The first lessons were not glamorous. They were humiliating. Operation Torch, November 1942. American forces landed in French North Africa and immediately discovered that having aircraft did not help. If the airfields were wrong, the weather turned, and the equipment was still trapped on ships. The aviation engineers were supposed to build forward strips quickly, but beach logistics broke down. Trucks could not be unloaded. Heavy machinery sat in cargo holds. Men waited ashore while the battle moved faster than the supply plan. Then the rains came. Tunisia became mud. Airfields that had seemed usable on dry ground began to fail. Aircraft sank. Aluminum mat buckled. Clay turned to soup. Engines revved while wheels dug deeper. The Allied air effort was being strangled by the ground itself. Brigadier General Donald Davidson, the senior aviation engineer in North Africa, went looking for ground that would not betray them. Near Telurgma in Algeria, between the Saharan and Maritime Atlas Mountains, he found a plateau with better drainage and made the decision personally. Engineer battalions began clearing and grading. On December 13, 1942, 11 days after Davidson's reconnaissance, a B-26 landed smoothly on the new field. More strips followed. Bombers and fighters moved off the drowned coastal fields and back into the fight. This was not yet the polished American system of 1944. It was the rough school where that system learned what failure cost. Equipment had to land earlier. Drainage had to be judged faster. Mat choice mattered. Soil mattered. The order of unloading mattered. An airfield was not only a strip of ground. It was timing, fuel, trucks, drainage, surfacing, repair, and men who could solve problems without waiting for the perfect instruction. Then came Kasserine Pass in February 1943. A defeat sharp enough to leave a mark on the entire U.S. Army. German armor broke through. American formations scattered. Equipment was abandoned. Men died or were captured in the desert. German officers looked at the wreckage and saw confirmation of what they wanted to believe. The Americans had money. They had factories. They did not yet have soldiers. They called them a dollar army. But the aviation engineers took something different from North Africa. They took lessons, painful, practical lessons. What mud does to optimism. What missing equipment does to a schedule. What rain does to aircraft. What happens when a battle outruns the engineers who are supposed to support it. 18 months later, those lessons landed in Normandy. And this time, the schedule was brutal on purpose. June 6, 1944, D-Day. The 9th Engineer Command under Brigadier General James B. Newman had been given an airfield program so aggressive, it sounds reckless even now. Emergency landing strips on D-Day. Refueling and rearming strips within days. Advanced landing grounds shortly after. Dozens of fields planned across the expanding beachhead within weeks. An emergency landing strip did not need to be beautiful. It needed to be flat enough for observation aircraft and damaged planes. A refueling and rearming strip needed to turn fighters around closer to the fight. An advanced landing ground was more serious. A runway long enough for fighter groups, surfacing, dispersal, fuel, water, power, maintenance space, and traffic control. The goal was simple. The Air Force had to cross the channel, not only in the sky, on the ground. 17,000 aviation engineers began landing with the invasion force. Some came ashore while the beaches were still being fought over. Advanced elements of the 819th Engineer Aviation Battalion reached Omaha Beach only hours after the first assault waves. They were not arriving after the battle. They were arriving inside it. The job was not to wait for quiet. The job was to build before quiet existed. Their equipment worked close enough to German artillery positions that by normal construction standards, the site should have been abandoned. But this was not normal construction. It was a frontline race between dirt and fire, and the engineers kept grading. Behind Omaha Beach, near Saint-Pierre-du-Mont, the 834th Engineer Aviation Battalion began work on what became A1, the first American airfield on the continent after D-Day. Construction began June 7. By the evening of June 8, the strip was operational, roughly 60 hours after the landings. C-47 transports used it to evacuate wounded men back to England. On June 13, P-47 Thunderbolts of the 366 Fighter Group began operating there. Think about that from the German side. On Monday, reconnaissance sees farmland. By the end of the week, that same farmland is launching fighter bombers against your roads. No concrete had cured, no permanent hangars had risen, no old map could warn you. The runway had appeared inside the tempo of the battle, and the aircraft coming from it were now part of the battle's tempo. Other fields followed: Crickville-on-Besson, Cardinville, Carentan, Saint-Lambert, Tours-on-Besson. Some used steel mat, some used prefabricated Hessian, some used wire mesh, some used compacted earth, when nothing better could be made ready fast enough. The material was not the point. The aircraft did not care whether the runway was elegant. They cared whether the wheels stayed above the mud. By June 19, fighter bomber groups were operating from Normandy soil. By the end of the war in Europe, the 9th Engineer Command had built or rehabilitated 241 airfields across France, Belgium, Holland, Luxembourg, and Germany. 241. Many were never meant to last. That was the genius. Build, fly, advance. Pull up what can be reused. Move east, build again. The airfield stopped being a monument. It became a tool, and American tools went where the work was. This is the part German commanders could feel before they could explain it. A tactical aircraft is most useful when it is close. A fighter bomber based too far behind the lines loses time in transit. Response slows. Fuel disappears into distance. Pilots arrive late or with less time over the target. But if the field moves forward with the army, the sky gets closer. That was what the Marston mat system really bought. Not simply runways. Proximity. A P-47 could take off from a field that had been Pasture days earlier, reach the front in minutes, strike a convoy or gun position, return, refuel, rearm, and go again. To the German soldier on a road in Normandy, Allied air power felt like weather. Always overhead, always near, always arriving too quickly. Field Marshal Erwin Rommel understood the effect immediately. In reports after D-Day, he described Allied air superiority as overwhelming. German road movement by daylight became almost impossible near the battle area. Columns hid under trees. Staff cars waited for darkness. Supply trucks moved at night and died in ditches by day. Rommel had seen Allied air power in North Africa. What Normandy added was something even worse. The bases moved. The Luftwaffe was tied to airfields the Allies could find, bomb, crater, and attack again. The Americans kept building new strips so close to the front that German response cycles broke down. You cannot bomb an airfield that did not exist when your last reconnaissance mission flew. You cannot plan around a base that spends 6 weeks in one pasture and then vanishes toward Germany. That was the operational humiliation. The sky was everywhere, because the ground under the sky would not stay still. The contrast with German construction could not have been sharper. The Luftwaffe had built many of its air bases as permanent installations. Concrete runways, hangars, workshops, barracks, hard stands, electrical systems, drainage. They were impressive, rational, durable, and slow. By 1944, many Luftwaffe construction units had been absorbed into Organization Todt, the vast empire of forced labor and concrete that had built so much of Germany's military infrastructure. Organization Todt was capable of immense work, but it was not built to throw an expendable runway into a meadow and abandon it a month later. Its logic was mass, permanence, control. The American logic was speed, sufficiency, mobility. The Germans built as if the war would hold still long enough for concrete to justify itself. The Americans built as if tomorrow's front line was already asking for a runway. This was not because German engineers were stupid. They were not. German engineering was formidable. The problem was doctrinal imagination. They had inherited a construction culture that saw permanence as proof of seriousness. The Americans had learned to accept impermanence as a weapon. A German engineer might look at a rough mat runway and see a compromise. An American aviation engineer looked at it and saw aircraft in the air before the enemy could react. That is the difference between a flaw and a doctrine. Across the world, the same idea was being proven on islands. In the Pacific, the Navy's construction battalions, the Seabees, took the same American construction culture and pushed it into coral, jungle, volcanic ash, rain, shell fire, and heat. They were often older than the infantrymen around them. Carpenters, electricians, welders, equipment operators, pipe fitters, men who had built for a living before the Navy put them in uniform. Their motto could have described the whole American airfield war. Build where you are. Build under fire. Build what is needed. Then build the next thing. On Guadalcanal, Marines captured the Japanese airfield site at Lunga Point in August 1942. It became Henderson Field. The fight for that runway became the fight for the island. Japanese aircraft bombed it. Warships shelled it. Rain and mud punished it. Craters opened. Engineers and Seabees filled them. The 6th Naval Construction Battalion arrived and surfaced the runway with Matt while the battle still raged. After Japanese battleships hammered Henderson Field in October, Seabees patched the field quickly enough that aircraft could return to operations. That was the principle again. Damage the field. Repair it faster than the enemy can make damage decisive. On Tinian in 1944, Seabees transformed captured ground into one of the largest airfield complexes in the world. They built Northfield with 4 massive runways long enough for B-29s. Coral had to be blasted, crushed, hauled, graded, compacted, and shaped into the geometry of strategic bombing. Months after Marines landed, heavy bombers were rolling down runways built by construction battalions on an island the Japanese had held. From those runways, aircraft would later fly missions that ended at Hiroshima and Nagasaki. That fact is terrible in its consequence and undeniable in its engineering meaning. The reach of air power depended on men who could build the launch point. On Iwo Jima, the price was even more visible. Seabees landed with the Marines in February 1945 under some of the worst conditions of the Pacific War. The 133rd Naval Construction Battalion suffered terribly. Yet within days, damaged airfield surfaces were being made usable, and soon crippled B-29s returning from Japan had a place to land instead of ditching at sea. The argument for the island was written in emergency landings. A runway could be a weapon. It could also be a life raft. In Europe, another version of the story unfolded in Italy. The Foggia airfield complex in southeastern Italy had been built originally by the Italians and fought over by the Germans and Allies. After the British Eighth Army captured the region in 1943, American engineers repaired, expanded, resurfaced, drained, and reorganized the fields for heavy bomber operations. By mid-1944, roughly 24 fields in the complex were operating. From that network, the 15th Air Force sent B-17s and B-24s toward Romanian oil, Austrian industry, southern Germany, and the Balkans. The Tuskegee Airmen flew from Ramitelli. Other groups flew from fields whose runways had been patched, extended, or surfaced by engineers who understood that strategic reach was not only a question of aircraft range. It was a question of where aircraft could live. Albert Speer later wrote about seeing the bombers crossing the Alps from the south as omens of the end. Those omens had addresses. They came from airfields built, repaired, and sustained by the same construction system that would later make Normandy feel impossible to German observers. The more you look at the war through airfields instead of aircraft, the more the map changes. The famous machines still matter. The P-47, the C-47, the B-26, the B-17, the B-24, the B-29. But every one of those aircraft needed a surface, fuel, maintenance, traffic control, access roads, drainage, storage, repair crews, and a way to keep operating after weather or enemy fire tried to close the field. Air power was not just pilots and engines. It was gravel, steel, diesel, survey stakes, truck convoys, repair crews at midnight, men carrying 66-pound panels until their shoulders ached, men filling bomb craters while other men listened for the next shell. The Germans often described Allied air power after the war as if it were elemental, a force of nature. It paralyzed movement, it cut roads, it destroyed columns. It broke attacks before they reached assembly areas. But aircraft do not become weather by themselves. They become weather when they are always near enough to arrive. That nearness was engineered, one steel panel at a time, one bulldozer pass at a time, one rough field after another. The question in the Normandy photo room had been, how did the Americans build an airfield in 3 days? The complete answer is larger than any single invention. They did it because American industry could produce the steel, because Liberty ships could carry it, because Caterpillar could build tractors in numbers, because the Army created aviation engineer battalions designed for the air war instead of borrowed from peacetime construction habits, because the CCC, farms, road crews, tunnels, dams, and factories had trained men before the Army ever met them, because those men accepted a practical truth that more elegant systems resisted. A temporary thing can be decisive if it exists at the decisive moment. The German system asked for permanence. The American system asked for usefulness. The German system built runways to remain. The American system built runways to follow. And in a war where the front kept moving, following was more important than remaining. Imagine the work from the ground level. A field is selected. Survey stakes go in. Bulldozers cut the high spots down and push fill into low ground. Scrapers move earth. Shape the surface. Drainage crews open ditches before the first rain can undo the whole job. Trucks arrive with stacks of pierced steel. Men lift, carry, drop, hook, lock. Lift, carry, drop, hook, lock. A runway begins as a line, then a strip, then a surface. At the edges, other crews prepare dispersal points and fuel areas. A control point appears. Access roads are improved. Repair sections organize panels for replacement. The field is still raw. The surrounding countryside still looks like farmland. There may be no proper buildings at all. But an aircraft comes in. The wheels touch. The surface holds. At that moment, the airfield becomes real. Not when the concrete cures. Not when the barracks are finished. Not when a headquarters map assigns it a neat symbol. It becomes real when the first aircraft lands and can take off again. That was the American standard, and by that standard, The Americans were building the impossible over and over. The men who did it rarely became famous. The 819th Engineer Aviation Battalion, the 834th, the 820th, the 816th, the 826th, the 832nd, the 833rd, the 846th, the Seabees at Henderson Field, Tinian, Iwo Jima, Okinawa. The aviation engineers who moved through New Guinea, the Philippines, North Africa, Sicily, Italy, France, Belgium, and Germany. Most of them went home and returned to the same kinds of work that had prepared them for war. Roads, farms, shops, engines, construction sites. They had not won the war in the usual cinematic way. They had not taken a bridge with a bayonet charge or flown a fighter over enemy territory. They built the place from which someone else could do those things. That is quieter. It is not smaller, because every close air support mission that arrived in time had a runway behind it. Every wounded man evacuated from a forward strip had a runway behind him. Every German convoy that could not move by daylight was being held in place by aircraft whose nearness had been built by somebody with a grater, a wrench, and a pile of steel mat. The air war was not only won in the cockpit, it was won in the mud beneath the wheels. By the end, the evidence was everywhere and almost nowhere. Across Europe, hundreds of temporary Allied fields had been built, used, stripped, abandoned, or converted. Across the Pacific, coral runways and island bases had stretched American air power across an ocean. Much of the Marston mat was pulled up, reused, scrapped, sold, melted, or turned into fences, bridges, barn floors, and local repairs. Fields went back to pasture. Hedgerows grew back. The photographs remained. So did the German testimony. We could not move. We could not assemble. We could not bring supplies forward by daylight. The aircraft were always there. And the reason they were always there was not magic. It was not luck. It was not only American wealth. It was a system, a steel panel with 87 holes, a 13-ton bulldozer, a ship that could carry a runway, a battalion built around construction instead of ceremony, a generation of men who knew how to make hard ground useful, and a philosophy ruthless enough to choose a rough airfield today over a perfect one too late. That is what the Luftwaffe photographs captured. Not just a runway in a field, a different way of making war. One that treated an airfield not as a monument, but as a temporary tool of movement. One that understood the sky belonged to whoever could keep moving the ground underneath it. The pasture was empty on Monday. By Thursday, fighters were taking off from it. And from that rough strip of steel and dirt, the war above Normandy began to move at American speed.